Hello, ladies and gentlemen. Welcome to today's session. Today we will discuss electrochemistry. So in this chapter, we will master these techniques which include electrolysis, which we use electrical energy to make chemical energy to happen. The definition and different situation we will discuss later. And then hydrogen and oxygen fuel cell, we are using chemical reaction to produce electricity. So let's have a look on all these one by one. Let's start with what is electrolysis. Electrolysis is breakdown of ionic compound that is in either molten state or aqueous state using electricity. So we use electricity to break ionic compound back to atom or molecule state. For the electricity setup, we must have a power source, and then here is the wire. Here have two electrodes. Usually we are using the inert electrode, and this electrode must be able to conduct electricity. The two most famous inert electrode is graphite. Graphite is carbon and also platinum. Of course, there's one more situation that we are not using the inert electrode. We are using active electrode. It will fall on the fourth situation of electrolysis. We learn later. Last is the electrolyte. Electrolyte must be ionic compound that is in molten or aqueous state. This is electrolyte. So covalent compound, we cannot do electrolysis, only ionic compound. For the electrode part, we have two electrodes, one part attached to the positive of the battery, one part negative. If it attached to positive, it's anode. If it's attached to negative, the short is negative, then it's a cathode. Anode will attract anion, which is the negative charge ion. Cathode will attract cation, which is the positive charge ion. Then we see a bit deeper. Let's say I'm using sodium chloride. Every time I will write down cathode and anode first, and then positive ion will attract to cathode. Sodium ion is the cation, the positive ion will attract to here, and then chloride ion will attract to anode. So electrolysis, the ion we will discharge, means we will remove the charge. So at last the sodium will accept the electron and become sodium metal, and then chloride will lose the electron to form back chlorine gas and then release the electron. The anode will release electron, so the electron will passes from anode to the cathode. This is how the electrolysis happens. So after we know the basic setup, let's see some question. The diagram shows electrolysis of aqueous copper sulfate using inert electrode. Just now we already know inert electrode include graphite or platinum. Which arrow shows the movement of electron? According to pancake, positive is anode. Anode attracted negative ion. Negative ion lose their charge, which means electron will be released from here. Electron will go into this part and then give the electron to the positive ion, so it will cause the positive ion also discharge. That's why the movement of electron follow path B. Next question, in the electrolysis diagram, oxidation occur at electrode 1, reduction occur at electrode 2. Oxidation means that their oxidation number increase. For example, chloride ion, if they form chlorine and release electron, the oxidation number is changed from -1 to 0, no charge when they are molecule, and ion get attracted and then is release electron. So here is anode, then here confirm is cathode. Electron will move from here to here, 1 to 2. Direction of positive ion will attracted to cathode, number 2, so it's A. After we learn about the basic setup, then we go to the fourth situation of electrolysis. Electrolysis, majorly we can form it in molten state or aqueous state. As we previously know, molten means we melt the ionic compound, and then aqueous means that we dissolve them into water. So aqueous state, they have more ion. Why? Because they have one extra compound, water. They will form hydrogen ion and hydroxide ion. What happened in the electrolysis for the molten state situation? So let's say we are using molten sodium chloride. Here is positive anode, this negative cathode. Every time I will write down cathode, and anode. First of all, we need to know which ion will get attracted to cathode, the positive ion. So what are the positive ion in molten sodium chloride? Only sodium ion. What is the N ion that will get attracted to anode? It's only chloride ion. So molten state is the easiest situation because only one cation, one N ion. So we will only discharge this and this. So sodium ion get discharged if they receive one electron, they will form back sodium metal. All metal except copper are gray metal. So if they ask you what is the observation that you see at cathode, then you just say gray solid deposited. How about anode? The chloride ion will form chlorine gas and then release electron, and then we balance them. The thing that you can see at anode is green gases released. So this is what will happen at cathode and anode. Okay, so after we see the molten state, then we go to aqueous state. We are using aqueous and ACl. So cathode anode. Cation ion will attracted to cathode sodium and hydrogen ion because it's an aqueous state have H2O. Anode here not only Cl minus, also have OH minus. Aqueous situation, you need to choose which ion will get discharged. The one that have less reactive will get discharged. Hydrogen is usually lower in reactivity. There are a few ions that is lower reactivity than hydrogen ion, which include copper ion, silver ion, and gold ion. So other than this, always choose hydrogen. And then how about anode here? Anode confirm we will choose hydroxide ion. So this is what will happen at cathode. Hydrogen gas release, fizzing, or colorless gas release. Then how about the hydroxide ion? It will become oxygen, water, and electron. Oxygen gas will release is again a colorless gas or fizzing. So how can we differentiate hydrogen and oxygen? Of course, the test for these gases, hydrogen we can use burning splinter and it will produce a pop sound. Oxygen we will use glowing splinter and it will relighten the splinter. Until here we already covered the difference between molten and the normal aqueous situation. Let's try the molten situation. The student carry out an electrolysis experiment on molten lead chloride. So every time I see the question is electrolysis, then I will directly write down my cathode and anode. In molten state, lead 2 will get attracted, chloride will get attracted to here, and then no H plus and OH minus. So we directly discharge this and this. So we can confirm lead get discharged by getting electron to form lead, a gray color metal, because as I say, only copper is brown color solid. Other than this, all gray color solid. And then Cl will form chlorine gas, which is the green color gas. After I list down the information, only I will do the question. Then they say chlorine gas forms at the anode and escape from the apparatus. So explain why lead to chloride need to be molten before it can conduct electricity. The reason is just because we need the mobile ion. Write the half equation that occurring in anode. We already write down. These two are the half equation in cathode and anode. So they request for anode, then we just copy it here. Next, state the test for chlorine gas. So chlorine gas is a acidic gas, so we can use damp litmus paper. Chlorine also a bleaching agent, so that's why after it change it to acidic red color, at last it will bleach it and form white color. And then describe what is observed at cathode. Lead is formed, but observation you cannot tell us lead is formed. You can only tell me a gray solid deposited. Next question is all related to the normal situation, or they mention is diluted situation. They say it's aqueous copper sulfide. I write down cathode, anode, aqueous. So copper sulfate, which means Cu2 plus and H plus. Sulfate means SO4, 2 minus and OH minus. They are using carbon electrode, inert electrode. For cathode, there are a few ion that is less reactive than H plus, which is copper, silver, and gold. So discharge copper. Accept electron, so will become copper metal. And then here always OH. which statement is correct? First, bubbles of hydrogen gas form at anode. Anode here, oxygen. Okay, wrong. Bubbles of oxygen form at cathode. Cathode here, oh no, it's copper metal deposited, so also wrong. Copper is deposited at anode. No, it's at cathode. The blue color of solution fade. The blue color of the solution is because of the copper ion. In periodic table chapter, we learn transition element have colored ion. Copper 2 ion have blue color. If you forgot this part, you can refer back to the periodic table video as above link. So, blue color of the solution phase. As we know, copper ion is used to form copper metal. So the concentration of copper ion will continue to reduce. That's why the color will fade and at last colorless solution. So answer is D. Next question. Dilute aqueous potassium chloride. Platinum electrode is the inert electrode, which row identify the product at each electrode. So here we'll discharge H plus because do not have copper, silver, gold. Here we'll confirm choose OH. Hydrogen always in diatomic, so that's why we balance like this. So we can confirm cathode will have hydrogen, anode will have oxygen. So answer is C. Next question, aqueous copper sulfate. The thing that will form at cathode is copper and anode is oxygen. So they ask you state the meaning of electrolyte. Ionic compound. It must be in molten or aqueous state. Take the terms given to Roman numeral 2 in the name of copper 2 oxide. This is the oxidation number. State what happened to the color of aqueous copper sulfide as the electrolysis progressed. As the same as previous question, we are using copper ion. So you just tell me fade, or you tell me it will become colorless. Then write the ionic half equation for the copper at cathode. You need to receive 2 electrons to form copper. Give the formula of ion that forms oxygen. The formula is just OH minus. Okay, so after we're familiar what is the difference between molten and aqueous normal or dilute situation, let's see concentrated solution or they are using active electrode. Active electrode means as long as they are not using the inert electrode, graphite, carbon, platinum, if they are not using this, then it categorized as the active electrode. Here, application of it is the electroplating. Both of this situation, they will only affect anode. Both of them do not affect cathode. So let's see how it looks like. For example, we use sodium chloride. If it's a dilute or normal sodium chloride and concentrated sodium chloride, what is the difference? For the cathode, it's exactly the same. We'll choose back H, but it will affect anode when it's concentrated situation and only affect group 7. If you have any group 7 ion, I will choose group 7 ion. And then here is the same. So this is when concentrated situation, it will affect the anode, group 7 will get discharged. How about active electrode? Let's say we are using copper electrode and then the solution, let me change it to copper chloride. Since we are not using graphite or platinum, so the anode, the active electrode will involve in the electrolysis. Active electrode, they will form ion. So electrolysis will always break down ion back to their original state, but active electrode will change to ion. Cathode is still as the same. Choose copper. At last, you see the anode will be thinner and thinner. For cathode, brown solid deposited here. If I want to ask deeper, what is the color changes? Here, copper ion is used, but here, copper ion is produced. So the total concentration of copper 2 ion do not change. So no changes in color. The active electrode situation is very important because the electroplate technologies is very useful. We cover a metal with the less reactive metal, so it is shiny and it won't get rusted so easily. So let's say I have a ring. I want to electroplate it with a layer of silver. We still want the ring, so we cannot put it in anode because anode itself will change to ion. You wouldn't have the ring anymore. So that's why this ring you must attach to cathode, the negative part. The metal that I want to coat on my ring, put at anode. Let's say I want to coat it with silver, so silver put at anode. And then the solution would be a salt solution that contains metal ion that I want to plate on it. I choose silver nitrate. Anode here, the silver metal will change to silver ion and electron. Silver ion will discharge at cathode. So you see a layer of silver metal is deposited on the ring. So your ring will look very nice and very resistant. We see the concentrated situation first. So it says concentrated aqueous magnesium bromide. Concentrated situation for a star here, it will affect group 7. So I will choose group 7 ion. Here, as usual, we choose back hydrogen ion. This is what happened at anode and cathode. Positive anode, negative cathode. So positive electrode is this, negative electrode is this. So it's A. Next question, the electrolysis of concentrated sodium chloride and molten sodium chloride. This question is a mixture. So we see two parts. Concentrated NaCl, so I put star here. Here I will choose H, here I will choose Cl. And then here molten sodium chloride. Then we need to identify what is electrode 1 and 2. Electrode 1 is a negative. Negative is a cathode. Cathode will form hydrogen. Electrode 2 is a positive anode. So anode here is a chlorine. So I choose B. We go for the paper 4 question that says the electrolysis of concentrated potassium bromide using graphite. Concentrated means we will choose group 7 at anode. Here we choose hydrogen. Here we choose bromine. Then we can start the question. They say hydrogen will form at cathode, correct. Bromine will form at anode, correct. Then it says the electrolyte become aqueous potassium hydroxide. After we discharge hydrogen and bromide, ion that left there is potassium and hydroxide. That's why we will left potassium hydroxide. So state what is the meaning by term electrolysis. Breakdown of ionic compound by using electricity. Next, state why graphite is suitable to use at electrode. It's inert and conduct electricity. Write an ionic half equation for the formation of hydrogen at cathode. So it's just this. Name a type of particle responsible for the transfer of charge in the wire. So in the very beginning, we already know in the wire, electron will pass us through. Name the type of particles responsible for the transfer of charge in the solution, ion that is able to move. State the name of product formed when electricity is passed through dilute aqueous potassium bromide. If it's dilute, we'll choose OH. The name of the product. So at anode, it will form oxygen. Cathode is still hydrogen. Okay, next P4 question. They say the table gives information about electrolysis of two electrolytes. Carbon or graphite electrode is used in each experiment. So they are using this and this. So for aqueous copper sulfate is, so we will choose copper because it's less reactive, and then here is confirmed OH. So for the positive anode, we will release oxygen. So colorless bubbles will form, and name of the product is oxygen. Negative electrode is cathode. Copper will form, brown solid will deposited. So this is copper metal. Next, we talk about the concentrated aqueous sodium bromide. Concentrated situation to affect the group 7. So the positive anode here will form bromine yellow liquid. So hydrogen is produced at negative electrode cathode during electrolysis of concentrated NABR. So we see from here, the cathode is this. See two reasons why graphite is suitable to use. Anode can conduct electricity. Name the particle responsible for conductivity of electricity in wire. So wire confirmed is electron. If they say the solution, then would be the mobile ion. We try one more question on P4. They say they are electrolyzed using these. So they say they repeat by using concentrated NaCl. So initially, the first part they say is dilute. Then after this, part E, they say they want concentrated. So again, we write, when it's concentrated situation, it affects the group 7 in anode. At anode, you see the chlorine gas. So what is observation? It's green gas. Cathode will choose hydrogen, so we can say it's fizzing or colorless gas is formed. Next, the student added litmus to the solution after electrolysis of concentrated NaCl. So we already know it will discharge H plus and Cl. So the ion that left in the solution is Na and OH. So NaOH alkali, litmus will be the blue color because it's alkaline form, NaOH. At last, carbon electrodes are used because they are inert. State another element that can use instead of carbon. If you write graphite, answer is wrong because graphite is carbon. So you need to tell me is platinum. Next, we go to the active electrode situation. So the first question says concentrated copper chloride. Since this question, they are using copper electrode, not carbon, not graphite, not platinum. So here the electrode will involve and the copper itself, the electrode itself will become ion. And then the cathode is as usual, we choose copper. Then the question says the positive electrode, which is anode, the electrode will form ions. The metal will reduce. So that's why it's decreasing at anode. For negative cathode, more and more copper metal form here. So it's increased. So it's B. Next, they have two experiments. Experiment 1, they use aqueous copper sulfide by using graphite. Experiment 2, they're using copper sulfide by using copper electrode. So we write down both. Experiment 2, they're using copper electrode, so put a star at anode. Because the copper electrode itself will become ion. Cathode, as usual, we discharge this. So, which statement identify the half equation at one of the electrode? So they say at experiment 1, anode here is this. Oh, yes, it's this. In experiment 1, the half equation for cathode is Cu2 plus. So this is wrong. In experiment 2, the half equation for anode is this. No, we are changing the electrode to ion. So this part reverse. In experiment 2, the half equation for cathode is this. This is the negative ion impossible. It appears in cathode, so it's wrong. So answer is A. Okay, we enter the active electrode question that involve electroplating. So see this question. They say how to plate a nickel object with silver. The electrolyte, we must choose the thing that we need to plate with. So must choose silver solution. We know that nickel is the thing that I want, just like the ring. So we cannot put it at anode. If I put it at anode, this nickel object will gone. So we put it at cathode, negative here. We already know it's A. We need to coat it with silver, so that's why silver must put at anode, so it will become thinner because it will deposit it here. Okay, iron can be electroplate by zinc, make it resistant to corrosion. We show about electroplating iron with zinc. Iron is here, I want to coat with zinc. So the solution, electrolyte, I must use zinc. This iron I want, so I cannot put it at anode. I must put it at cathode. Then we already know it's this. Paper 4 question. The electrolysis of aqueous copper sulfide is repeated using copper electrode. So what happened at anode? So you see the copper electrode become thinner and thinner, anode dissolve. Next, spoon can be electroplate by silver. So name the substance used at the cathode and anode. So the spoon you still need, so cannot put at anode. Anode will dissolve. So we put spoon on cathode. Silver, I put it at anode. And then the electrolyte, we must put something silver. So we choose silver nitrate. It's easiest to choose the nitrate because the nitrate always can make electrolyte. The next, state 2 reasons why spoons are electroplate: prevent corrosion and improve the appearance. So after complete electrolysis, now we are dealing with cell. Cell, we are using a chemical reaction to produce electricity. In our syllabus, we are learning only hydrogen-oxygen cell, which we're only using hydrogen and oxygen to produce electricity. And the only product is water. That's why the advantages of using hydrogen-oxygen cell would be it's no pollution produced because it do not produce, for example, CO2, that is the greenhouse gases bad for the environment. And then it also less sound pollution because it's less noise produced. What is the disadvantages of using hydrogen-oxygen cell? First is the material to make the cell is more expensive. Second, it's difficult to store hydrogen. This is what you need to know for hydrogen-oxygen cell. So first question, hydrogen-oxygen fuel cell can be used to produce electricity in vehicles. Write the symbol equation. We are using hydrogen react with oxygen to form only H2O. Next, state one advantage of using hydrogen-oxygen fuel cell instead of petrol in vehicles. So it is no carbon dioxide is produced. Next, fuel cells are used to generate electricity. Name the reactant in a fuel cell: hydrogen and oxygen. Name the waste product: only water. Next, which statement about hydrogen oxygen are correct? Hydrogen oxygen can react to produce electrical energy. Yes. Hydrogen and oxygen can be made by the electrolysis of dilute and ACl. Dilute, then we choose this and this. So yes. So it's D. Next question. Which statement about hydrogen oxygen fuel cell is correct? So hydrogen is extracted from clean, dry air. No, we are getting hydrogen from the petroleum, the cracking. We'll learn it in hydrocarbon chapter. The only product is carbon dioxide. No, the only product is water. The reaction is endothermic. We'll learn in thermochemistry, endo means they will absorb energy from the surrounding. So it's no, it will release energy to the surrounding. No toxic gases are produced. Yes, because it only produces water. Next, hydrogen-oxygen fuel cell can be used to produce electricity power cars. Petrol produces carbon dioxide and carbon monoxide when it powers car. State one adverse effect of carbon dioxide and carbon monoxide. So carbon dioxide will cause global warming. Carbon monoxide will cause toxic. Then state one disadvantage other than cost of using hydrogen-oxygen fuel. So difficult to store hydrogen. Okay, we successfully finished the electrochemistry. So I hope you learned something in this chapter, and don't forget to subscribe, like, and share my video. If you have any question, please feel free to comment here, and see you in the next class. Bye-bye.